The following presentation is about translating word problems into systems of equations. A system of equations is a collection of two or more equations with the same set of unknowns. In this first example, we have Pleasantville currently has a population of 482 people, and the population is dropping 19 people per year. Crescentfield has a population of 207 and is growing by 36 people per year. When will the two towns have the same populations, and what will the population be? The first step is to define your variables. A trick to determining which are your unknowns is to reread the statement that has the question in it. When will the two towns have the same population, and what will those populations be? So our two unknowns are going to be to let x equal time in years to represent when, and y equals the population of the towns. When we reread this sentence, we notice that we have a starting point and the population is dropping at a constant rate. So we're going to use y equals mx plus b when there's a constant rate of change. So for Pleasantville, we have y equals negative 19x plus 482. Negative 19 comes from dropping 19 people per year, and 482 is the starting point. For Crescentfield, we have an increasing population of 36 people per year, so it's a positive 36 for our slope, and a starting point of 207. So the system of equations for this problem is y equals negative 19x plus 482, and y equals 36x plus 207. Second example, we have Manuel is selling chocolate for a fundraiser. Boxes of chocolate cost $5 each, and bars of chocolate cost $2 each. This weekend, he sold a total of 20 items and made a total of $64. Determine how many types of chocolate he has sold. Defining our variables, our unknowns are each type of chocolate. So we have boxes of chocolate and bars of chocolate. So we're going to let x equal the number of boxes and y equal the number of bars. When we reread, we notice that we have a total of 20 items and a total of $64. One trick is to organize your information in a table if you have two total amounts. So we're going to make a table with 4 rows and 4 columns. In the columns go our unknown, total amounts, cost per unit, and total costs. Our first unknown are boxes of chocolate. We're going to use x to represent the total amount because we don't know how many boxes of chocolate we have. $5 per box. So for a total cost at $5 per box, we're going to multiply 5 times x. And then bars, we don't know the number of bars, so we're going to let that equal y. The cost is $2. Total cost is 2 times y. And then our final row, we're going to have our total information. Total amount was 20 items. Total cost was $64. Our two equations are going to come from the total amount and the total cost. The word total means we need to add items together. So our two equations are going to be x plus y equals 20 and 5x plus 2y equals 64. In our final example, Christina owns 21 pairs of shoes. The number of pairs of boots she owns is 3 less than twice the number of pair of heels she owns. How many pairs of each type of shoe does she own? Our two variables come from the types of shoes. So we know we have boots and heels. So x is the number of pair of boots and y is the number of pair of heels. In this first sentence, we have a total of 21 pairs of shoes. So that's going to be x plus y equals 21. And then as we read carefully through the second sentence, we're going to translate this sentence into a mathematical expression. So we have the number of pair of boots. That represents x, or can be represented by x. The word is equals 3 less than means we're taking away 3 from something. And we're taking away 3 from twice the number of pairs of heels. So since we designated heels as our variable y, we have 2y minus 3. Our final systems of equations are x plus y equals 21 and x equals 2y minus 3.